Hi, this is Marwa, and today we will have another video about functions where we're going to discuss how to find the inverse of a function. We will see how to find that inverse algebraically, how to graph a function and its inverse, the relation between the domain and range of both functions, and we will discuss if the inverse is a function or not. So let's see what we have here. Now, in this question here, it says, graph the function and its inverse. Is the inverse a function or not? We will see. The function we have is y equal x squared plus 2. Now, we know that y equals x squared plus 2 is a quadratic function. So the first thing I'm going to do is I'm going to graph it before I'm even going to look through how to find its inverse. So I have the function y equals x squared plus 2. I know it's a quadratic function. I know that it is shifted 2 units upwards. How do I know that? We have a video about transformation functions that discusses vertical and horizontal shifts that you can look back to. So I know that the vertex of this function is not going to be here. No, this is going to be the vertex of my function. So I know that one of the points is at 0 and 2. Now, I can actually find values for x and y and graph the function. I know that the 0 and 2 is my vertex. I can take 2 points before the value x equals 0, let's say -1 and -2, and 2 points after, and make a small table just to see how my graph will look like. So if I have -1 for x, -1 squared is 1 plus 2, y will be equal to 3. If I have -2 as a value of x, -2 squared is equal to 4 plus 2 is 6. If I have a value of 1, 1 squared is 1 plus 2 is 3, and 2 squared is 4 plus 2 is 6. So the values of x and y I have as follows, so I can actually graph this function. I already know that 0 and 2 is the first one. I have -1 and 3, so this is my second point. I have 3 and 6. This is my third point in both sides of the y-axis. I'm going to try my best to graph this function. It is a problem, and as we can see here, it looks upwards and its vertex is at the point 0 and 2. So far all we did is that we had a graph of a quadratic function and we graphed this. Now, what if I want to find the inverse of this function? How do I find the inverse? Now, an inverse of a function is basically done by switching the inputs and outputs. What does that mean? The input of this function, the values of x, are going to be the output of its inverse. So if I want to find the inverse, I am going to switch inputs with outputs. So the values of x are going to become values of y, and the values of y are going to become values of x. So what did I do? I switch x with y. To find the relation, an inverse relation algebraically, you're going to switch inputs with outputs, or what we call switch domain and range. Okay, so after I do that, what I'm going to do, I am going to solve for y to find the relation that is opposite to the function I already have. When you solve for y, you will have x minus 2 equal to y squared. If I square root both sides, it's going to be y equal positive and negative square root of x minus 2. Now, how do I graph this function? Well, one way of doing it, we already said that we are going to switch the values of x and y. So why don't I do that? I'm going to switch the values of x and y from the original functions I had. So here I had -2 and 6. This is going to become 6 and -2. I had -1 and 3. This is 3 and -1. So the values of x and y has been changed. 0 and 2 will become 2 and 0. 1 and 3 is going to be 3, 1. And then 6, 2. Now, let's graph this function. Now I have its table, and I'm going to graph it. So at 6, I have a value of -2. Here it is. This is the inverse of this point. At 3, I'm going to have -1. So here at 3, this is -1. This is the second point. Then at 2, we're going to have 0. Then at 3, we're going to have 1. Then at 6, I'm going to have 2 again. By connecting these points, I will have the graph of the inverse of the relation. Now let's look what we have here. Each one of those points is the inverse of the other one. Like here we had the point 0 and 2, its inverse was 2 and 0. This point, which is 1 and 3, its inverse was the point 3 and 1. Now we have seen how to find the equation of the inverse relation algebraically, and we have seen that the values of x and y have been switched for both of them. Now let's see, is what we have here a function or not? Now what does specify a function? For a relation to be a function, every input has to have only one output. What does that mean? Like when you put -2 into the equation, you'll get only one answer, which is 6. When I put -1 into the equation, you will get only one answer, which is 3. But this does not happen here. Here, when you put 6 into the equation, you'll get two answers, -2 and 2. How? Well, 6 minus 2 is 4, and the square root of 4 is positive and -2. Even on the graph, we can see it. If I here substitute with a value of 3, you will get two values, 1 and -1. If I substitute for 6, I'm going to get 2 and -2. So having two outputs makes this relation not a function. I can tell by many ways. From the equation, if I substitute, I'll get two outputs, so I know it's not a function. From the table, I will find that the values of x are repeated. Here I have 6 and here I have 6 with two different outputs. I have 3 and 3 with two different outputs, so that does not make it a function. Also from the graph, there is something that we call a vertical line test. If I draw a vertical line here, that vertical line will intersect with the graph in more than one point. If that happens, it means I have more than one output, so it means that it's not a function. So here for sure, I can tell that the inverse of the function we had is not a function. Now, what about the domain range? It wasn't asked here, but I want you to take a look at that. Now, I have the function y equal x squared plus 2. I know that its domain, just like any other polynomial function, the domain of this function is going to be all real numbers, which is from -infinity to infinity. Its range, as I can see here, starts from 2 to infinity. And I can tell that also by the shifting. It was shifted 2 upwards, so instead of starting from 0, it started from 2. Now, what about the domain and the range of the inverse relation? Well, I told you that it's going to be switched. So the domain of this relation is going to be the range of the main function, which is 2 and until infinity. And its range is going to be the domain of the main function, which is from -infinity to infinity. So here we have seen that I can have a function, and I can use that function to find its inverse by switching the values of input and output. If you switch x with y, then you're going to solve for y. After you do that, you can actually graph both functions by making simple tables, or if you know how to do it. If I graph the first function, I can switch the values of x and y and graph its inverse. I can tell whether the inverse is a function or not by many ways. Just by looking at the equation, if I see that every input has one output, it's a function. Every input has more than one output, then it's not a function. If I look into the table, if I have repeated values of x, it means every value of x has more than one output. So that does not make it a function. If I look at the graph and I draw a vertical line, and that vertical line intersects the graph in more than one point, it's not a function. So I know now that I have more than one way to know the function. Now I just want to highlight what is this line we have here. This line is the line y equals x, or f of x is equal to x, and whenever you have to graph a function and its inverse or a relation and its inverse, this line acts like a line of symmetry. Like this is the reflection on this, on the line y equals x, and it's always that line, not any other line. I hope this has been helpful for you and that you have a better understanding of how to find inverse relations algebraically, how to determine if the inverse is a function or not, and the relation of domain and range of a function and its inverse. Thank you so much for watching.